So let's use the process covered in the last video on for finding absolute extrema on a closed and bounded interval. Let's use that on this problem. So let's let f of x equal x to the fourth minus 2x squared plus 3, and we want to find the absolute extrema of f on the interval -1 to 2. And let's find also the locations where those extrema occur. So first of all, let's perform the first step of the process. Let's find f prime of x derivative is equal to is equal to 4x cubed minus 4x, and the derivative of 3 is 0, so it just equals that. So we can simplify this a little bit. This is equal to 4x x squared minus 1. So what we want to do now is find the places where the derivative is either 0 or undefined. So let's solve the equation 4x x squared minus 1 equals 0. We can readily see from looking at it that that's going to happen where x equals 0 or plus or minus 1. So the answer is that the solutions to that are x equals 0, 1, and -1. And we can also clearly see that f prime of x is defined everywhere. Oops, sorry. Everywhere. In other words, since f prime of x is just a polynomial, it doesn't have any points where it's undefined. So, we're doing everything we can to check to carry out the process and check for that, but there are no points where it's undefined in this case. So, what we want to do now is evaluate the original function at all the critical numbers and all the endpoints, which means that we're going to have to find f of -1, f of 0, f of 1, and f of 2. So note that we're finding f at -1 for two different reasons. It doesn't really matter, because we have to find it if it meets either of these definitions. But -1, a -1 has a point where its derivative is 0, and also happens to be an endpoint as well. We're finding f of 0 and 1 because those were points where f prime was equal to 0. Sorry, I meant to say f prime was of -1 was 0. We're finding f of 0 and f of 1 because those are points where f prime is 0, and then we're finding f of 2 because x equals 2 is an endpoint of the interval. So f of -1 is going to be -1 to the fourth is 1, minus 2 times -1 squared is 2, plus 3, and this is equal to 2. F of 0 is 0 minus 0 plus 3, which equals 3. F of 1 is going to be 1 minus 2 plus 3, which is 2 again. And f of 2 is 2 to the fourth is 16, minus 2 times 2 squared is minus 8, and then plus 3, that gives us 11. So, and let me just mark in here that this was end point and critical point. This was critical, and this is an endpoint. So those are the reasons that we had to check f at those values. So we can see is that the lowest value that appears is 2, and it actually appears in both places. So this appears to be the absolute min. And the highest value that appears is 11, so that's the max. And we also got a 3, but that's right in the middle between 2 and 11, so it's neither a min nor a max. So we can now conclude that the absolute min is equal to 2, and it occurs at x equals -1 and x equals 1. So it occurs in two places, but there's still only one absolute min. And the absolute max is equal to 11, and it occurs at x equals 3.